Okay, on to 9.4. In 9.4, we're going to take this one step further and give us another way to solve. 9.4, we're going to solve quadratics by something called completing the square. So this is solving solving quadratics by completing the square. And this is called complete the square. The technique we're going to use today to solve this called completing the square. Okay, last week we had looked at solve. I'm just going to write this off to the side. We had solved by taking square roots. And we got this x squared by itself, set equal to some value. I took the square root of both sides. And then I got some sort of answer that was plus or minus the square root of d. What completing the square is going to let us do is take something that has that middle term. Notice, remember, this did not look like this. Remember, we said we don't want that bx term in the middle because there ends up being, it's not two variables, it's both x, but one is squared and one is x, and it makes it a little more difficult to solve. We want to get something where I have something squared by itself so I can take the square root, and completing the square allows us to do that. So I'm just going to make some words here. Let's take, I will say 4x squared plus bx. So if something looks like this, and even if it doesn't, we're going to figure out how to do it as we continue to go. But I have an x squared term and I have this bx term. I'm going to say you can add a constant. And if you remember back to ax squared plus bx plus c, c was that constant, and that's what we'll call it again here. You can add a constant, and we will call that c, to the expression so that, and I'm talking about this expression right here, x squared plus bx plus c. So I'm going to add a number here, this constant on the back side, and this ax squared plus bx plus c, we're going to add this c that makes this a perfect square trinomial. I'm going to say this is completing the square. That process is completing the square. And remember, a perfect square trinomial is something like that. Remember, if my a, the number in front of my x squared, is a perfect square and my c is, we can see if it factors into a perfect square trinomial. What multiplies to be 3 and adds to be 6, or if I take the square root of a and the square root of c, remember this was not a, this was x plus 3 squared. That's a perfect square trinomial. that's how it factors. And I want us to think about what's going on when we solve this up here, x squared is equal to d. If I can make this look like this, and it factors to something that looks like that, remember this x plus 3, that's like one big variable. That is an x squared. And last week when we had something that x squared, or x plus 3 squared is equal to, let's say 9, and I asked you to solve that, we got away from, well, okay, I will expand this out, subtract 9, set it equal to 0, and use zero product property. Now, last week, we just took the square root of this. And that's what we're going to look to do with those expressions that look like the x squared plus bx. We're going to get them to look like a perfect square trinomial, so then I can finish it by taking the square root. There's some steps that we're going to follow. I'm going to just say to complete the square of x squared plus bx, we are going to do the following. Step 1, you are going to find 1/2 of b, meaning I'm going to take, remember, let's just look at our words. If I take 1/2 of b, I'm going to take that b and divide it by 2. I'm going to take half of it. Find 1/2 of b, and I'm just going to put in parentheses here the coefficient of x. It's that value right there. Whatever's in front of that x, the coefficient of x, I'm going to take that value of b and I'm going to cut it in half. Once you cut that value in half, you are going to square the result. You are going to square the result. Meaning, if this was 6, I would half it, which was 3, and then I'd square it, which would be 9. The third and last step, add the result to x squared plus bx. And then what we do is we can factor it. Factor the result. We'll say the resulting expression because that's what we're going to get. As the square of a binomial. And that square of a binomial, what I'm talking about, is that right there. So if I look at this one right here, and I just started out with that expression, x squared plus 6x. I would take half of b, which is 3, and square it, which is 9, add it to that expression, the original one, which was x squared plus bx, and it results in this perfect square trinomial. I then factor it into the square of a binomial, and it's going to allow me to solve. So let's look at some examples. Let's do, let's start with x squared minus 9x. And we're going to complete the square on this. So to follow my steps from up here, I look at my b term, the coefficient in front of x. I have it, which is just 9/2, right? I take that b value, so it's the b divided by 2. So this is step 1. I take that 9, actually it doesn't need to be negative there. Oh, it is negative, I have it there, negative 9/2. Step 2 is I square that, so it's negative 9/2 squared, which gives me 18 gives me 81/4. I take that 81/4 and I add it to that expression in step 3. So this becomes x squared minus 9x plus 81/4. This is then going to factor into a perfect square trinomial. It's going to give me the square as a binomial. I can take the square root of this x squared. I can certainly take the square root of 81/4. This becomes x subtract 9/2 squared. Let's do another one. I'm not going to write the steps out this time. X squared plus 10x. I take half of my b value here. I'm going to take half of 10, square it, and then add it to this. Half of 10 is 5, and then I would square it. So it's 10 divided by 2 is 5. 5 squared, 25. I rewrite the expression, add in that value right there, and hopefully you can see that this is indeed a perfect square trinomial, and it is x plus 5 squared. That's completing the square. We are going to use this to solve here in a little bit. Try one of these on your own. Let's do x squared minus 4x. Okay, I would take half of my b term and square it. Half of 4 is 2, negative 2, but of course it's not going to matter because I'm always squaring this last term. It's always going to be positive. And remember, if I think back to my perfect square trinomials, all I had was a plus b squared and a minus b squared. That c was always positive because it was a positive times a positive and a negative times a negative. And then my middle term just dictated my sign. Back to this one though, if I half 4, it's 2, and 2 squared is 4. So this is x squared minus 4x plus 4. Again, I took that negative 4, I divided it by 2, which gave me negative 2. I take negative 2 and I square it, and that's where that 4 came from. This is x minus 2 squared. We complete the square to help us solve. This is going to be another tool we can put in our toolkit to solve. So this we are going to say solving a quadratic x squared plus bx is equal to d. So now we are going to use the complete the square to actually get an answer for this. we're just going to have the instructions as solve x squared minus 16x is equal to negative 15. And again, we have all sorts of ways that we could go with this. I could add this 15 to both sides, set it equal to 0, and factor it. And we might do that here off to the side, but we're going to use completing the square. By completing the square, because you are going to be given choices on how you want to solve these. Completing the square is something that is always going to work. It could always work, no matter if this is factorable or not. This is factorable, but we're going to solve by completing the square. So I've got this equation here. It is, remember, to complete the square, if it looks like x squared plus bx, which this one does, I take half of my b term and I square it to make my c, turning it into a perfect square trinomial. So this becomes x squared minus 16x, half of my b term and squaring it, half of 16, negative 16, divided by 2. That's going to give me that negative 8. I square that negative 8, and that's what goes right here. And you are still going to have negative 15. So this blank where that c goes, that's going to be my plus 64. Now remember, back to equation solving. If I'm solving this and I add 64 to this side, I have to add 64 to this side. So whatever I fill in for my value of c here, when I got that equal sign here, I gotta stay balanced in my equation solving. I will have to add 64 to both sides. And you can see right here, because I add 64 to both sides, and look at my original equation, I haven't changed the value of it, what x is gonna be, because if you're doing it to both sides, you're not changing it. This is what we need to recognize now as a perfect square trinomial. X minus 8 squared is equal to negative 15 plus 64, or 64 minus 15 gives me 49. Now I'm right back to where we were in 9.3. I can solve for that expression there by taking the square root of both sides. If I take the square root of both sides, x subtract 8 is going to equal plus or minus the square root of 49, which is 7. Now I can add 8 to both sides. So this becomes x is equal to, I would have 8 plus or minus 7, giving me 8 plus 7, which is 15, or 8 subtract 7, which is 1. And I get my solutions of 15 and 1. And again, if I recognize this up here, x squared minus 16x, and I'm going to make that plus 15 is equal to 0. All I did was move this over, set it equal to 0, because before, and I asked you to solve this, the only way we'd be able to do it is to try to factor it. And this does subtract into x subtract 15 times x subtract 1, giving me solutions or zeros or roots of 15 and 1, and that's exactly what I got right down here. This will always work. Completing the square will always work. Let's try one more here. Let's get something maybe where we're rounding. So let's do x squared plus 12x is equal to negative 8. So here's where it comes in. Now, unlike this one, if I add 8 to both sides, if I add 8, factors of 8 that give me a sum of 12, would only be 4 and 2. That's a sum of 6. 7 and 1, which is 8. This one is not going to factor. This is where completing the square comes in real handy. I can actually get this square root, get a decimal approximation, and have some answers there. And I'm going to do it by completing the square. I take half of my b term, which is 12. You could go ahead and even write what you're going to do here, making sure to remember I'm going to take half of this squared, it's going to go there, and I'm going to have to add it to both sides. Half of 12 is 6, because 12 divided by 2 is 6. I would then square 6, which is 36, which goes right there. What you do to one side, you must do to the other. We complete the square to make this a perfect square trinomial, because now this will factor into x plus 6 squared is equal to negative 8 plus 36, or 36 minus 8, gives me 28. Hopefully you're recognizing right now 28 is not a perfect square, but that doesn't matter. I can still solve this by taking the square roots of both sides. So I am going to get my calculator for this one though, because when I take the square root of both sides, x plus 6 is going to equal plus or minus the square root of 28. And if I put that into my calculator, gives me, let's go to the nearest hundredth. So I'm going to say that is 5.29. Plus or minus 5.29. I can then solve this for x by subtracting 6. So this becomes x is equal to a negative 6 plus or minus 5.29. I will take negative 6 plus 5.29. So if I take that negative 6 plus 5.29, that gives me a negative 0.71. And then if I subtract it, negative 6 minus 5, well, that'd be a negative 11.29. And I've got my solutions right there. That is how we solve to complete the square. Now that is going to work all the time, but you notice in these two examples, the coefficient in front of my x squared was just a 1. Just like when we were factoring, they're easy to check for factoring when that coefficient is a 1. But what if it's a value other than 1? That's what we're going to do down here. So it is going to look like this, back to ax squared plus bx plus c is equal to 0, or it could be some number. The bottom line is we're going to use completing the square to do this. So I'm going to say solve 2x squared plus 20x minus 8 is equal to 0. And we're going to use completing the square. Because remember, I could always see if this could factor. And we're going to look at that again as well. We'll come back to looking at this as factoring. What I first want to do is get this to look like my x squared and my x on the same side. I'm going to add 8 to both sides. Now if it's set equal to 0, like I said, if I was given the choice I may try to see if this factors first. I could see I could take out a 2, and I could see if I could factor. It's always worth a shot, but remember, completing the square is always going to work. I'm going to take this 8 and add it. That makes this 2x squared plus 20x is equal to, and by adding 8 to both sides, it just becomes 8. To complete the square, you want this value to be a 1. Because 1 is a perfect square. 2 is not a perfect square. As it sits right now, it's not going to factor into a perfect square trinomial, but I'm going to make it. So I'm going to divide it by 2 to get this coefficient to be a 1. Remember, if I divide everything by 2, I don't change the value. So once I do that, if I divide everything by 2, that leaves me with x squared plus 10x is equal to 4. Now hopefully you can see, even if I went and set this back equal to 0 by subtracting 4, there's no factors that give me a product of negative 4 and a difference of a positive 10. I'm going to complete the square from this step right here, just like we did up here. I will take half of my b term and square it. And remember, I'm going to take this 10x, I'm going to add some c term by taking half of my b and squaring it. And remember, you are going to have to add that to the other side too to maintain the equality in the equation. So if I take 10 and divide it by 2, that's 5. 5 squared is 25. 25 goes there, 25 goes there. This is now a perfect square trinomial. X plus 5 squared is equal to 29. I'm going to leave this in radical form this time, put it into a decimal as well. Once this squared is by itself, I take the square root of both sides, leaving me with x plus 5 is equal to plus or minus the square root of 29. I can now subtract 5. X is equal to negative 5 plus or minus the square root of 29. And I'm going to round these answers when I get it. You will have 2. And I'm going to use my calculator to get them, and I'm going to go to the 100th again. So I will say negative 5 plus the square root of 29, and it gives me 0.385. I said to the 100th, so second decimal, so this is 0.39. I can then take negative 5, subtract the square root of 29, and I get a negative 10.385, which is going to be 10.39, and I've got my 2 solutions right there. Nothing changes if you're going to use completing the square by putting this value out in front. I just divide everything back through to get the coefficient to be a 1, and then I go into completing the square. And it doesn't matter whether you get fractions or nice integers here. This will always work. This will always work. The last thing we need to talk about with completing the square is finding maximum and minimums. What I am talking about with a maximum and a minimum is, remember what these graphs look like. And we got to go back to what we know about graphs already. I'm going to make a couple quick little XY coordinate planes here and get the general shape of what our quadratics are. And remember, those shapes are parabolas. Those are the U's. And I could have something that looks like this. This is the lowest point of that parabola, this is the minimum. It's the lowest point of where it goes. If I have a parabola that opens down, that top height, hopefully, this makes sense, that would be the maximum. It's the tallest point. It's the vertex of the parabola, and when it is opening down, it's a maximum. When it's opening up, it's a minimum. And these values are going to be important in real life problems. Remember, if I was tossing something, that maximum, the vertex of the parabola, that's going to be the maximum height. And that's going to be an important value. Remember about these graphs. If it's opening up, the coefficient in front of my x squared is positive. This would be ax squared plus bx plus c. When it opens down, that a just becomes negative, just like our absolute values, just like our slope, just like anything. When that negative coefficient is there, it was decreasing. Y was decreasing. So if I have something like that looks like this with a negative a squared, you're going to be looking for the maximum. You're going to be looking for the minimum when that a is positive. Here's an example. I'm going to say find the minimum. Find the minimum. And we'll say the equation is y is equal to x squared plus 4x minus 1. I'm going to get this solved for y, but I'm going to use completing the square to do it. First things I want to do is get this one on the other side to get this x squared plus 4x by itself. Because how I'm going to find the minimum and maximum is by completing the square. And it's going to go back to what we did with absolute values with that vertex form where we found the lowest point of that absolute value. Add 1. This becomes y plus 1 is equal to x squared plus 4x. I am going to now complete the square right here by taking half of my b value and then squaring it and then adding it to both. So half of b is 4 divided by 2, which is 2. And then I would square 2, and that's 4. This value right here needs to be a plus 4. And remember, you are going to add it to the other side as well. So this becomes, if I add that 4 plus 4 plus 4, this becomes y plus 5 is equal to, and now I've got this perfect square trinomial, x plus 2 squared. I then need to get y by itself by subtracting 5. Y is equal to x plus 2 squared, subtract 5. When it looks like this, this is what we call vertex form. This vertex form has a value in h of k. And remember, I take the opposite of h and k to find my vertex. This looks like exactly what we did with absolute values. It's going back to the same h and k form. I told you it would come back up, and now it is. The opposite of h is -2. The k value is -5. What you can do when you complete the square and put this in what we call vertex form is find the vertex of the parabola. And now I just want to picture what this looks like. It has a vertex of -2, -5. It'd be somewhere right there. If I would expand that out, and I look right back up here, that a value is going to be positive. This is a parabola that opens up, that has a vertex of -2, -5. Because that a value is positive, the minimum value you're looking for is that minimum right there. And that minimum, how low it is -5. The minimum value on this is -5. It is the lowest point on the x-axis, or I'm sorry, the y-axis. The deepest, lowest point of that parabola. And you can see it doesn't matter what happens. If I have a negative out front, if I happen to go through all of this and this happened to be a negative and I would factor that out, it just changes how this parabola opens up. It would still have that vertex, but that a value would tell me it opened down, and then you're dealing with a maximum. And your maximum is still going to be -5. Minimum when it opens up, when that a value is positive. It is a maximum when it opens down, and that a value would be negative. Bottom line is, we complete the square, solve it for y, get it in vertex form, identify our vertex, see if it's a positive or a negative out front. If it's positive, you know it opens up. You're talking about a minimum value. You would be talking about a maximum if that a value was negative and it opened down.